So I have told the concept of what is a zero vector, unit vector, that is in types of vectors. That is what are equal vectors, zero vector, unit vector, and negative of a vector, co-initial vectors, non-zero vectors, and even what is a position vector we have seen, and even algebra of vectors we have seen, and also properties of vector addition. Okay, so what is the commutative law, what is the associative law, subtraction of vectors, and what are the collinear vectors and what are the coplanar vectors. Okay, so even in the page number 1.5.7, you have the collinear vectors. One of the theorem is there. So you may have the chance of getting for the 5 marks question. And even in the coplanar vectors, one theorem is there. In a there is a it is there. Whatever the code will be there, no, that number is 1.5.9. Okay. So that theorem we have. So with the help of that also, means it is you have the chance for getting the 5 marks. Okay. And even 5 marks question, that is in section A, first and second question will be from the block 1. So I have told how to find when 3 vectors are given, how to show that they are collinear vectors or they are coplanar vectors. So yesterday we have seen the problem on coplanar vectors. So whenever 3 points are given, that is 3 vectors will be given. Those 3 vectors you have to write them as a determinant, and if you find the determinant value, if you get that value as 0, then we call it as a coplanar vectors. So if you get the determinant value as it is not equals to 0, then we call it as a non-coplanar vector. Okay. So even for the 4 vectors, if it is given in the question, how to find the coplanarity, the condition, I have told the problem yesterday. Okay. So after that, one problem we'll do on the collinear of the vectors. So if small a, b, c are non-coplanar vectors, then show that the points minus 2a plus 3b plus 5c, comma a plus 2b plus 3c and 7a minus c are collinear. So these points you have to show that they are collinear. So for collinearity, the condition is that whenever 3 points will be given, the collinearity condition is that is AB is equals to some scalar. So you will get some scalar value into BC or AC, anything. So 3 points you will take as capital A, capital B and capital C. So if you find AB value, BC value or AB and AC value, so there will be some relation between these 3 points. So if you get AB is equals to some scalar into BC or some scalar into AC, then we call that these 3 points are collinear. The collinear definition is nothing but whatever the 3 points are there, if they lie on the same line, then we call that as a collinear points. Okay. So you have these concept in a collinear and coplanar in a 3D, you have 3-dimensional geometry, that is in the 5th semester. Okay. So the problem is, if A comma B comma C are non-coplanar. So this is the MEQ question is there. That is a model examination question. After the completion of the unit, you will have this one. That show that the points minus 2a plus 3b plus 5c, comma a plus 2b plus 3c and 7a minus c. Okay, are collinear. So we have to show this one. So first thing is, let us denote the given points as, let us denote the given points as A comma B comma C. Okay. So the points, whatever it is there, 1, 2, 3, you are denoting them as capital A, capital B, capital C. Okay. So then if you find AB vector, it is equals to OB minus OA, means OB and OA are position vectors. Okay. So in the sense, whatever here we have taken A, B, C, those are the position vectors of, this is OA, this is OB and this is OC. Okay. So now OB minus OA. So it is A plus 2B plus 3c minus, here minus already, then minus of minus is plus 2a minus 3b minus 5c. Okay. So if you do the simplification, a plus 2a means it is 3a plus 2b minus 3b means it is minus b. Next plus 3c minus 5c means it is 2c. Okay. This is the value we got for AB. Either you can find BC or you can find AC. Okay. So if you take AC, AC is OC minus OA. So OC is this one, that is 7A minus C minus A is minus of minus plus 2A minus 3B minus 5C. Okay. So 7A is there, 7A plus 2A means it is 9A. So here we are not having B, so the value is 0. 0 minus 3B means we get minus 3B. And minus C minus means minus 6C. Okay, we can write this as AC is equals to, we'll take 3 common from this, what you get 3 into, that is 3A minus B minus 2C. Okay, so what is this value? This value is AB, no? That is 3A minus B minus 2C. So this AB is equals to, that is AC is equals to 3 into AB. It is 3 into AB. So whenever you will get it, that is AB is equals to some scalar. What is this value? This value is some scalar of AC. We got some scalar of AB. So whenever you will get the relation like this, then we called the points A comma B comma C are collinear. Okay. So therefore AC is equals to 3 into AB. Okay. So therefore AB and AC are collinear. So automatically, the whatever the points are there, hence the points A comma B comma C are collinear. Okay. So this is the procedure how to find whenever the key points are given to show that these are collinear. So if you are not getting any relation like this, then we call that the points are non-collinear. The main thing is in on the line. If you think this is the line, that is whatever the points are there, A, B, C. If the 3 points they lie on the same line, then we call the points as the collinear points. Okay. So next we have the concept of what is dot product, what is cross product is there. So in that, how to find the angle and how to find the condition of orthogonality or condition of perpendicularity. So like this, you have here whatever the unit one is there, it is the all basic concepts of vectors. So if you have the idea of that is, if you have the idea of intermediate vector algebra, so the main same concepts will be there. Okay. So next we have the concept of dot product is there. So dot product, or we call it as a scalar product of two vectors. Okay. So if you know these definitions in a block 2, block 3, block 4, whatever the topics are there, easily you can solve them. Okay. Dot product are scalar product of vectors.
నా ఫేస్ ఏం కనబడవద్దు అని
Okay, so we have seen the just now we have seen the collinear of the vectors. Next, if you'll see the dot product of the vector is there, or we call it as a scalar product of vectors. So 1.5, if you'll see, it is a collinear and coplanar of vector definitions you have. So many example problems are there. So try to practice those example problems. So it is 1.5.14. So show that the points whose position vectors are collinear is there. Next, if you'll see 1.5.15, so two vectors are given, that is if 2i plus 4j minus 5k and I plus 2j plus 3k are sides of a parallelogram, then find the unit vectors parallel to the diagonals. So this is also important 5 marks question, 1.5.15. So next we have the So next we have the concept of dot product of, it is R of is there actually. It is R scalar product of vectors. So we call it as dot product or scalar product of vectors. So in the dot product, in the sense we define it as A dot B, that is vector A dot vector B. And it is defined as, that is A dot B is equals to modulus of A into modulus of B cos theta. Okay, where theta lies in between 0 and pi, where theta is the smallest non-negative angle between the vectors A and B. Okay, so even the representation is there. 0 is the initial point here. From that, B and A are the two vectors. Okay,
So main thing, how to represent the dot product, it is A dot B. And how you will find further whenever 2 points are given, how we find the dot product for those 2 points. Okay. Next note is there, no, in that note, the dot product of two vectors is a scalar. So whenever you find the dot product, then the vectors, whatever the resultant you will get, that will be a scalar. Okay. So two vectors will be there. If you do the dot product for them, whatever the resultant answer will be there, that is a scalar, in the sense you will get some real value. Okay. The scalar product of two vectors is proportional to the length of each vector. Okay. These are the note points you have. Next here, properties of the dot product is there. So in this, the main thing is dot product satisfy the property of commutative. That is, the dot product of two vectors is commutative. It is satisfying this property. And even this is the same we have. That is, if m is a scalar, m greater than 0, these two conditions also it satisfies. Next important one is condition for orthogonality. This even we call this condition for orthogonality as condition for perpendicularity. Okay. So condition for the perpendicularity is nothing but A dot B equals to 0. Whenever you find the dot product of the two vectors, if you will get the value as 0, then we say that the two vectors are perpendicular to each other or they are orthogonal to each other. So when they are orthogonal or perpendicular to each other means when the theta value lies, when the whatever the theta is there, no, what is the dot product? A dot B is equal to modulus of A modulus of B cos theta. So whatever the theta is there, the theta value will be pi by 2. Okay, so pi by 2 in the sense 90 degrees, cos 90 degrees value is 0. So that's why whatever A dot B is there, that value is equals to 0. Okay, so even you have the proof for this one, condition for orthogonality. Just if you know the definition, it's enough for you. And the main important one is here you have, no, in dot product, I dot I value will be 1, j dot j value will be 1 and k dot k value will be 1. Okay. But if you take the other, that is I dot j or j dot k or k dot I, those values will be 0. Okay. So these are the very important while solving the problems. You should know what is the value of I dot I, j dot j or k dot k. So whenever you do the dot product, so I dot I you will get it. So if you know this concept, then directly you can write that value as 1. Okay. So this is the important one concept. After that note we have. So just now we have seen the perpendicularity. No, now we have the parallel of vectors. If A dot A comma B are parallel vectors, then A dot B is equals to modulus of A modulus of B, that is cos theta, that whatever theta value is there, that theta value is 0 degrees. Okay. For perpendicularity, it is 90 degrees. For parallel, if the two vectors are parallel, then the theta value will be 0. And we know that cos 0 value is 1. So A dot B equals to modulus of A modulus of B. So this value is when the direction of two vectors is the same, when they have the same direction. And it is equals to minus of modulus of A minus B whenever we have it as opposite direction. When the two vectors are in the opposite direction and they are parallel to each other, then you will have the negative sign. And if they go in the same direction, then you will have the positive value. Okay. Next important is the length of a vector. Length of a vector means if A is a non-zero vector, A dot A. So in place of B, we are taking here A. So if you substitute the same one in the definition of dot product, A dot A is equals to, that is mod A cos 0. So you will get it as modulus of A whole square. So whenever you take the square of that one, then you can write it as root of A dot A. So length of a vector is equals to modulus of A equals to root of A dot A. Okay. This is the very important one. If you know this concept, you can solve the problems. Next, in this only, projection of is there. Projection is the important one. Geometrical representation of scalar product is there. In this only, projection of A on B. Second equation is there, no? 25 page numbers. If you see the equations, how to find the projection of A on B or projection of B on A. One problem will be there. He will ask for 5 marks question. Okay. Find the projection of A on B for the given vectors, he will tell. Okay. Next, you have the distributive property of scalar product. That is A into B plus C is equals to, that is A dot B plus C is equals to A dot B plus A dot C. Okay. Or second, we know that is the left hand distributive will be there, right hand distributive will be there. Okay. B plus C dot A is equals to B dot A plus C dot A. Even the proof is there for this one. So proof is not asked, just if you know that concepts, it's enough. And this is also important for solving the problems. In 27 page number, dot product in terms of components, it is there. So we take the vector A and vector B as the components. That is vector A is equals to A1I plus A2J plus A3K. And vector B is equals to B1I plus B2J plus B3K. So when you find A dot B, whatever the resultant will be there, that will be equals to, here we have, see, A1 into B1 plus A2 into B2 plus A3 into B3. So how you will get this one? Why? Because I dot I plus J dot J plus K dot K value is 1. So you will get the resultant as like this. So next one is angle between the vectors. If two vectors are given and theta is the angle between those vectors, then we will get cos theta is equals to A dot B by modulus of A modulus of B. Okay. Even if you want to find the theta value, theta is equals to cos inverse of A dot B by mod A mod B. Okay. So on this also you will have the problem. So if you see the example 1.6.11. So find the dot product of the vectors. Two vectors are given. We have to find the dot product of that one. So A dot B is equals to, so first write the vector A, then put the dot sign and then write the vector B. So when you do the dot product of this one, I dot I, J dot J, K dot K will become, value will become 1. And whatever the other values are there, if you do the simplification, you will get it as the resultant as a scalar. So just we have seen no dot product of two vectors is a scalar. So here, when you find the dot product, the resultant value will be scalar. So next one is, for what value of x the vectors A and B are perpendicular. So what will be the value of x in the given vector such that these two vectors will be perpendicular to each other. Okay. So we know the condition of perpendicularity. It is the A dot B equals to 0. Okay. So now substitute A dot B, that is A vectors and also B vectors, and find the dot product for them. So if you find that product and if we equate to 0, then we can find the x value. Okay. Next one is 1.6.13. Find the angle between the vectors. Two vectors are given. You have to find the angle between the vectors. If theta is the angle between the vectors, then the formula is cos theta is equals to A dot B by modulus of A modulus of B. Okay. So dot product you have to find, and modulus means we know the length of the vector is root of whatever the vectors coefficients are there, ijk coefficients will be there, no? Those you have to find the squares for them. So with the help of that, you can find the theta value. So problem is in the 1.6.13. Okay, these are the very important problems in the unit 1. Next one is, if vector A, vector B, vector C are three vectors such that A plus B plus C value is 0 and modulus of A value is 3, modulus of B value is 5, modulus of C value is 7, then find the angle between A and B. Okay. Here one condition is given. The condition is that A plus B plus C is equals to 0 is there. Okay. So from that we can write that A plus B is equals to minus C. And if you do the square on both sides, it is in the form of A plus B whole square, that is A square plus B square plus 2AB. So in that you substitute the given values in the question. So if you substitute those values, in between what we have 2 into A dot B. A dot B means modulus of A, modulus of B, cos theta. So with the help of that, if you do the simplification, we can find the theta. Okay. So the angle between A and B is 60 degrees here. This is also regularly asked question 1.6.14. Next, even 1.6.15 example is also there. This is also important one. Finding the projection of the vector on the vector. So projection of the vector means one vector, if you take it as A and another vector as B, then you have the definition is there for finding the projection of A on B. So the formula is here. If the projection of vector A on B, then A dot B by, you will get modulus of B. If he's asking in the question projection of B on A, so two types of questions will get. One will be projection of A on B, and next one will be projection of B on A. B on A means A dot B by, in the denominator you will have the vector A, that is a modulus of A. So here same dot product you have to find, and you have to find the modulus. Modulus in the sense quotient of ijk squares you have to find. Then you'll get the value of that one. Okay. Next we have the example 1.6.16. Find a unit vector perpendicular to the plane. So we have to find the unit vector which is perpendicular to the plane A and B. Here two vectors are given, A and B vectors. We know the position vector. Vector x is equals to x1i plus x2j plus x3k. Be a vector perpendicular to the plane of A and B. Then A dot x equals to 0, B dot x equals to 0. So with the help of the given A and B values, if you substitute in this, we will get the two equations. And if you find, we need to find x1, x2 and x3 values. So from these two plane equations, with the help of the cross multiplication method, we can find x1, x2, x3 values. Then you will get the x value. So we know that a unit vector perpendicular to the plane of A and B is, that is vector x by modulus of x. What is a unit vector? We have seen it is denoted as A cap, A by modulus of A. Similarly, here we are finding the unit vector for x we are finding. So it is x by modulus of x. So this is also the important problem 1.6.16. So after that, find a vector on the xy. Check your progress is there. Check your progress. Fifth one is there now. Show that the vectors 1, 2, 3 vectors are there. We have to show that they are mutually perpendicular. Mutually perpendicular condition is nothing but A dot B equals to 0. So if when you find the dot product of this one, so then we can say that those are mutually perpendicular to each other. Next concept is dot product means we have seen A dot B. So if it is a cross product, so if you know the concept of dot product, and also so for solving the problems, two are important. One is the dot product, another one is the cross product. So cross product representation will be A cross B. A into is there, no, we call it as a cross. Okay. A cross B. So we call it as a vector product or cross product. Okay. Of two vectors A and B. It is denoted and defined as A cross B is equals to, their cos theta is there, no, for dot product. Here sin theta will be there for the cross product. And even the theta lies in between 0 and pi. So your theta is the angle between A and B, and A is a unit vector perpendicular to the plane A and B. Even in figure 1.2.4, you have the representation of the cross product. So condition is there here. Note is there, no? Note 3 conditions are there. After that, properties are there. We have seen that scalar product, that is the dot product, is a commutative, but cross product is not a commutative. So that is A dot B, the A cross B is not equals to B cross A. Okay. And even second and third conditions are there. But first two properties very important. So in dot product, we have seen the condition for orthogonality or perpendicularity. Here in the cross product, you will have the condition for parallelism. So the condition for parallelism is nothing but here we take the, that is if two A comma B are collinear, then theta equals to 0. And if they are parallel, then theta equals to pi. Okay. When they are collinear, you will have the theta value as 0. And if they are parallel, then theta value will be pi. There pi by 2 and also 0 we have seen. Here it is theta value is 180 degrees will be there. And another one is theta value is 0. So sin 0 value is 0. And sin pi value will be here. So cross product is there. With the help of that, we need to find this one. So sin theta equals to sin 0 equals to 0. Or even sin pi 180 degrees also equals to 0. Sin 90 is 1, sin 270 degrees is minus 1. But sin 0 value is 0, sin pi value, that is 180 degrees is also 0. So that's why A cross B equals to 0. There A dot B equals to 0 means condition of perpendicularity. Here whenever A cross B is there, it is equals to 0. Then it is the condition for parallelism. So you have to remember this concept, and even after that we have no, in dot product you have I dot I equals to 1, J dot J equals to 1. But in the cross product, I cross I, same if you have vectors, that is I cross I or J cross J or K cross K, those values will be 0. But if it is I cross J or J cross K or K cross J, those values will be 1. Okay. In page number 34, we have, that is in the cross product, J cross K will be I. So there we have one, no? There you will have, if it is different vectors are there in dot product, J dot K means you will get it as 0. But here in the cross product, you will get as this another vector, that is I vector. K cross J is equals to minus I, and K cross I is equals to J, and I cross J is equals to minus I cross K is